Hello friends, welcome to my channel rishi.edu. Myself Rishita. आज हम जो वीडियो लाए हैं उसमें हमारे देश का सबसे पहला सन मिशन आदित्य L1 के बारे में कुछ इन्फॉर्मेशंस बताया गया है। तो उम्मीद है वीडियो आपको बहुत अच्छा लगेगा, तो वीडियो को बिना स्किप किए अंत तक ज़रूर देखिए। और वीडियो शुरू करने से पहले अगर आप हमारे चैनल में नए हैं तो हमारे चैनल को सब्सक्राइब करके पास वाले बेल आइकन को ऑल पर सेट कर लीजिए, ताकि हम जब भी कोई नई वीडियो अपलोड करें उसके नोटिफिकेशन तुरंत आपके पास पहुंच जाए। तो चलिए आज का वीडियो शुरू करते हैं। Some basic informations about Aditya L1. Aditya L1 is a satellite dedicated to the comprehensive study of the Sun. It has 7 distinct scientific payloads which were developed indigenously, 5 by ISRO and 2 by Indian academic institutes in collaboration with ISRO. Aditya in Sanskrit means the sun. L1 here refers the Lagrange point 1 of the Sun-Earth system. For common understanding, L1 is a location in space where the gravitational forces of two celestial bodies such as the Sun and Earth are in equilibrium. This allows an object placed there to remain relatively stable with respect to both celestial bodies. Following its scheduled launch on 2nd September 2023, Aditya L1 stays earthbound orbits for 16 days, during which it undergoes 5 maneuvers to gain the necessary velocity for its journey subsequently. Aditya L1 undergoes a trans-Lagrangian 1 insertion maneuver, marking the beginning of its 110-day trajectory to the destination around the L1 Lagrange point. Continued. Upon arrival at the L1 point, another maneuver binds Aditya L1 to an orbit, that is halo orbit, around L1, a balanced gravitational location between Earth and the Sun. The strategic placement at the L1 point ensures that Aditya L1 can maintain a constant uninterrupted view of the Sun. This location also allows the satellite Aditya L1 to access the solar radiation and magnetic storms before they are influenced by Earth's magnetic field and atmosphere. Aditya L1 will stay approximately 1.5 million km away from Earth, directed towards the Sun, which is about 1% of the Earth-Sun distance. The Sun is a giant sphere of gas, and Aditya L1 would study the outer atmosphere of the Sun. Note, Aditya L1 will neither land on the Sun nor approach the Sun any closer. This is the picture of Aditya L1 satellites. These are the payloads, scientific payloads. 7 payloads are in this picture, and Swiss and steps are the subsystem of the payload aspects. Helios, Sweet, VELC, Papa, Magnetometer, Solex are the another payloads of Aditya L1 satellite. Scientific payloads of Aditya L1. VELC, Visible Emission Line Coronagraph. Visible Emission Line Coronagraph VELC is the prime payload on board India's first space solar mission Aditya L1. Simultaneous observations of solar corona in three modes, that is imaging, spectroscopy and spectropolarimetry. Observations of solar corona closer to the solar limb. Coronal magnetic field measurements. Observations of solar corona with high spectral resolution with high cadence. On-board artificial intelligence for the detection of coronal mass ejection (CMES). Scientific payloads of Aditya L1. SUIT SUIT Solar Ultraviolet Imaging Telescope. Solar Ultraviolet Imaging Telescope SUIT. SUIT instrument developed by Inter-University Center for Astronomy and Astrophysics IUCAA, Pune, in collaboration with ISRO, is a UV telescope to image the solar disk. SUIT provides unique opportunity to study the spatially resolved solar spectral irradiance near UV range relevant for sun climate relations, atmospheric dynamics of the earth. SUIT provides near simultaneous coverage of the solar atmosphere from lower photosphere to the upper chromosphere, important to understand the coupling and dynamics of the solar atmosphere. Scientific payloads of Aditya L1. HEL1OS, pronounced as Helios, is another payload of Aditya L1, which aims to study the phenomena occurring during solar flares. The payload is developed by the Space Astronomy Group, URSC. The instrument is a hard spectrometer. Study of the explosive energy release, acceleration and transport of electron using fast timing measurements and high resolution spectra. Study of the evolution of the cutoff energy between thermal and non-thermal emissions as a function of flare evolution and its relation with the spectral parameters of the accelerated electron distribution using high spectral resolution measurements. Quasi-periodic pulsation QPPS of hard X-rays during the impulsive phase of the solar flares to understand its connection with particle acceleration mechanism. Scientific payloads of Aditya L1. SOLEX, Solar Low Energy X-ray Spectrometer. SOLEX is a soft X-ray Sun as a star spectrometer. The main objective of SOLEX is to continuously measure solar soft X-ray flux 1 keV to 22 keV from the Sun-Earth Lagrange point 1. These solar soft X-ray measurements can be used to directly investigate the properties of the solar corona, which is dominated by magnetic field dynamics and high temperature plasma of over a million Kelvin. Scientific payloads of Aditya L1. Aspects: Aditya Solar Wind Particle Experiment. The aspects payload comprises of low and high energy particle spectrometers to carry out in situ measurements of solar wind particles at the first Sun-Earth Lagrange point, that is L1. Aspects is configured to have two different subsystems: SWIS, that is solar wind ion spectrometer, and another one is STEPS, that is suprathermal and energetic particle spectrometer. Aspects Aditya Solar Wind Particle Experiment will study the changes in the properties of the solar wind and its distribution system and light regime with the help of its subsystems, SWIS and STEPS. Scientific payloads of Aditya L1. PAPA, Plasma Analyzer Package for Aditya. The PAPA payload is developed by Space Physics Laboratory SPL, Vikram Sarabhai Space Center VSSC, Thiruvananthapuram. It aims at studying the composition of solar wind and distribution. The payload is conceived to have two sensors. One is SWIP, Solar Wind Electron Energy Probe, and another is SWICR, Solar Wind Ion Composition Analyzer, mounted perpendicular to each other and with a common PAPA processing unit PPU in the same chassis. It will observe the composition and the energy distribution of the solar wind. Scientific payloads of Aditya L1. Magnetometer. The flux gate magnetometer MAG is a dual triaxial magnetic sensor which is installed on a 6M 5-segment deployable boom mounted on the sun-facing deck of Aditya L1 spacecraft. The primary objectives of MAG is to measure the magnitude and direction of interplanetary magnetic field, that is IMF, locally, and to study the transient solar events such as coronal mass ejections CMES, the impact of these extreme solar events on near Earth space environment, and the detection of solar plasma wave signatures at L1 point. The MAG observations shall also supplement the solar wind studies carried out by other onboard in situ payloads such as PAPA and ASPEX on board Aditya L1 spacecraft. तो फ्रेंड्स, उम्मीद करते हैं आज का ये इन्फॉर्मेटिव वीडियो आपको अच्छा लगा होगा। अगर ये वीडियो आपको अच्छा लगा तो ये इस वीडियो को शेयर ज़रूर कीजिए और इस वीडियो को लाइक ज़रूर कीजिए ताकि ज़्यादा से ज़्यादा लोगों तक ये इन्फॉर्मेशन पहुंच सके। और आगे की वीडियोस के अपडेट्स पाने के लिए हमारे चैनल को सब्सक्राइब ज़रूर कीजिए। तो मिलते हैं अगले वीडियो में, तब तक के लिए गुड बाय एंड टेक केयर।